All right, let's take a look at lesson 17, completing the square and complex solutions. So for the warm-up, we are matching each equation in standard form to its factored form and its solutions. So the first two are difference of two squares. So you're going to have x plus 5 and x minus 5. Because the square root of x squared is x and the square root of 25 is 5. And then when you set those equal to 0, you get 5 and negative 5. For the second one, you have the square root of x squared is x, the square root of 5 is 5. And again, 1's plus, 1's minus. And so that goes with that one. And when you set those equal to 0, you get square root of 5 and negative square root of 5. Now, the last one's a little trickier. It's not a difference of squares, so you can't do it that way. But you can say, okay, well, x squared equals negative 25. Oops. And then take the square root of both sides. So plus or minus the square root of negative 25. Well, we know that's going to give us 5i. And so x minus 5i and x plus 5i are the factored form. And then 5i and negative 5i are the solutions. All right, in 17.2, sometimes the solutions aren't real numbers. So what are the solutions to these equations? So again, we're going to take the square root of both sides. And normally we'd have plus or minus, but with 0, there is no positive or negative 0. So x minus 5 equals 0. So x equals 5. So there's our answer for the first one. Again, take the square root of both sides. So x minus 5 equals plus or minus 1. And I'm actually going to rewrite that into two separate equations because it just makes it easier when we are looking at the solutions. All right, and then we're going to add 5 to both sides. So 5 plus 1 is 6, and 5 plus negative 1 is 4. So we get 6 or 4. All right, and then we're going to do the same thing here. Take the square root of both sides. So x minus 5 equals positive I, and x minus 5 equals negative I, because remember the square root of negative 1 is I. And then you're going to add 5 to both sides, so we have 5 plus I, oops, fix that, plus I, and then we have x equals 5 minus I. All right, now we're going to take a look at finding complex numbers, and we're going to solve by completing the square. Hopefully you remember how to do this from Algebra 1, but if not, we're going to take a look at how we can do this. All right, so there are multiple ways you can complete the square. I will show you one way. So the first thing I do is I subtract that 13 from the other side. Oops, that should be a minus 13 or a negative 13. All right, and then I'm going to take half of my negative 8. So half of negative 8. And then I'm going to square it. So that gives me negative 4. And when I square that, I get 16. So that's what I want to add to both sides, because on the left-hand side, that's going to give me x minus 4 when I factor that. And then I'll have 3 on the other side. And now we can go ahead and take the square root of both sides. So we have x minus 4 equals positive square root of 3, and x minus 4 equals negative square root of 3. And then I'm going to add 4 to both sides. So x equals 4 plus the square root of 3, and x equals 4 minus the square root of 3. You can write that as 4 plus or minus the square root of 3. Either one of those is an acceptable way to write the answer. All right, now we're going to take a look at the second one. We're going to do the same thing, but this time, instead of it being 13, we're going to subtract 19 from the other side, or from both sides. So we have negative 19. And then again, we're taking that middle term, so half that middle term, and then we're going to square that. So that's negative 4 squared, which gives us 16. So I'm going to add that 16 to both sides. Oops, that's supposed to be a 16. And then when we factor the left-hand side, we get x minus 4 quantity squared, and then that equals negative 3. All right, so then we're going to take the square root of both sides. And so we have x minus 4 equals positive I times the square root of 3, because remember, negative 1, square root of negative 1 is I. And then we have x minus 4 equals negative I square root of 3. So we have x equals 4 plus I square root of 3, and x equals 4 minus I square root of 3. Again, if you want to write it as 4 plus or minus I square root of 3, that is totally fine also. All right, so that's how you can use completing the square for that one. So let's, take a look at 17.4. How many real solutions does each equation have? How many non-real solutions? All right, so we just looked at completing the square for this one. So let's take a look back there. And we had 2 real solutions because we didn't have any imaginary numbers. Now they're irrational solutions, but we had 2 real solutions and 0 non-real. Okay. For the second one, we can go ahead and factor that. So we have x minus 4 quantity squared equals 0. So take the square root of both sides. And we get x minus 4 equals 0. So x equals 4. So that's just one real solution. And again, no non-real. 0 non-real solutions. All right, and then for the last one, remember we just completed the square for that one, so we can take a look back and see that both of our answers had I in there. So we had 0 real solutions. So 0 real solutions and 2 non-real solutions. And we can take a look at the graphs of these. I'm gonna actually keep that page up there. Oh, I don't want to do it that way. I'm gonna do it this way. That way I don't have to have it in my doc. There we go. I'm gonna make that a little bit smaller. So I'm gonna type in x squared minus 8x plus 13. And you can see that it crosses the x-axis in 2 places, and those are actually the approximations of the answers that we got in 17.3. So you can see that there's 2 real solutions. It crosses that x-axis in 2 places. Now let's take a look at, you know what, I'm going to make that purple if I can. Oops, there we go. I'll make that purple so it matches. And then we'll take a look at x squared minus 8x plus 16. And that one was pink. So let's see if we have pink there. Red is close enough. All right, and so you can see that intersects in just one place. And then when we type in our last one, we had x squared minus 8x plus 19. And you can see that that one doesn't intersect the x-axis at all, so it doesn't have any real solutions. So that's how you can check graphically if your equation is going to have 1 or 2 real solutions, no real solutions, or 2 non-real solutions.